One of the most important concepts in algebra is that of a function. So here in section 2, we want to try to get an idea of what we mean by functions. I've listed two groups of things here. On the left, you see a list of states. On the right, a list of numbers. And as the title says, the number of representatives for the state. Well, Alaska has one representative. Arkansas has 4. Texas has 36. Florida 27. And Kansas 4, same as Arkansas. Now this is the idea of a function. If we pick out any state on the left, there is a number on the right that goes with that state. And there's not two numbers that go with it, there's only one. Arkansas can only have 4 representatives, not 5, not 27, but 4. Another way of illustrating this relationship is a set. The braces on the end indicate the set, and the ordered pairs are in the order of state, comma, representatives. And so the state is what produces the answer for the representatives. And so this is the same concept, just illustrated differently. Here's another relationship. And do you see why this one is not a function? Well, Letitia has an 8, Andrew has a 7, Sandy has a 6, but Tony has 2 different numbers. You can't have 2 answers for one thing. Here's another illustration. You can probably see that if we have a job making $10 an hour, then $40 times $10 an hour is $400. 30 hours at $10 an hour is $300. 20 hours is $200. 10 hours is $100. Taking out all the words and just taking a look at the numbers, you see the ones on the left are what was producing the ones on the right. The ones on the left give the answers that we see on the right. Now, it doesn't really matter what order they come in, but those are the ideas. The numbers on the left that are being used to produce the answers are called the domain numbers, and the answers are called the range numbers. So we've got two groups of things. One's the domain and one's the range. Here's the same numbers, just mixed up a little bit, and still, here's the ones that go together, and that's the illustration of functions. The idea of a function, as you can see from the pictures we've been looking at, is every number in the domain has to give only one number in the range. Here's a similar type of setup, and the question is it a function? 1 gives a 5, 6 gives a 15, 3 gives a 9, 4 gives 11, 5 gives a 13, and 2 gives an answer of 7. That is a function. Is this one a function? Well, most people tend to look here at the 15 and say, no, it's not. What? It is a function. 33 gives only one answer. It's a 15. 42 gives only one answer. It's 15 also. It doesn't matter that two things give the same answer. One thing cannot give two different answers. That's a function. This one is not a function because 25 gives two different answers. Everything in the domain has to give only one answer in the range. Now, the one that we were looking at originally, here's another way of representing that in set notation with ordered pairs. The first number being the domain number, second number being the range number. And we want to know, is this a function? 1 gives a 15, 2 gives an 8, 3 gives a 13, 4 gives a 9, 5 gives a 0. Every domain number gives only one range number. Does every domain number give only one range number? And does every domain number give only one range number? In the beginning, a 1 gives a 5. At the end, 1 gives a 7. That's not a function. Another way, a common way, that you're asked to identify if something is a function is referred to as the vertical line test. It's the same thing we've been looking at. The x-axis represents the domain numbers. The y-axis represents the range numbers. Every number in the domain has to give one answer in the range. Here is a vertical line representing a number on the x-axis. The answer it gives, which is the y value where it intersects the graph, has to be unique. You cannot have two different answers. So wherever you put the line, it has to give just one answer. In other words, it has to cross the graph in one spot. That's a function. Look at this graph. Here's a vertical line. We don't need to go any further. The vertical line touches the graph in two spots. That is not a function. Here's a graph. Here's the vertical line. I'll run the vertical line down through there, and you can see wherever it is, it touches in one spot. That's a function, not a function. Now the question is for us to identify from looking at a graph what is the domain and what is the range. The domain represents the x numbers. The range represents the y numbers. So we look at the graph and determine where are the x numbers where we see a graph. Well, you can see here it's between -3 and 3. And so that's the domain, -3 to 3. Now, the less than and equal to implies, of course, that the dot is part of the domain. What about the range? Well, the y values, where we have a function, is -2 to 7. And again, there are dots at -2 and 7. Now, the idea of increasing and decreasing is pretty easy to catch on to. If you're going left to right along a graph, is it going up, or going down? You can see on this one, on the right-hand side, the blue part that's highlighted, if we were tracing with our pencil from left to right, that would be going up, increasing. So that portion of the graph represents increasing.